It fits into the local land use. It should be tested and certified to be able to show that it actually is doing what it says to do. And I don't have it as a bullet here, but it really ought to be managing the waste products from the building operations well too, within the waste hierarchy. Um, and so we'll get into each of these a little bit more as we go through. So let's go to the next slide. And first, in looking at water, again, these buildings are going to use quite a bit less water than a typical building would be. They'll have the high efficient sinks, water fixtures, sinks, etc. And the Water Sense program from EPA is a good program to be able to know that what you're getting is a good quality product that will use kind of sip water instead of using water. A good green building will also collect the rainwater on site. We want to keep it out of the storm sewers, keep it from polluting the flooding or polluting the streams. And then they'll use biodiverse, low maintenance native species, and they'll try and use either low or no irrigation or low flow irrigation so that, again, we're not using our water resources just to keep plants screened where we could have the plants that can make it through these summers and winters here in the greater Washington, D.C. The next slide is talking about them being healthy. The green buildings will use eco-friendly materials that don't outgas. So they won't be putting the pollutants into the indoor air or break down into the microplastics or other pollutants. It's kind of interesting to think about the plastic boards that they're putting down on walkways over wetlands, and are those going to be breaking down or not? So that we need to think about both in the building and without the building. The buildings are going to be airtight and have heat, ventilation recovery, and fresh air intakes to control, again, any pollution that comes forward inside and the humidity. And David will get into that a little bit more as he gets into the energy side. Next slide. They're also healthy in that they have accessible outdoor space for the people in the buildings, such as yards, or are going to be conveniently located near public parks, playgrounds, and also healthy food sources. Alexandria does have a goal of, I think, having every resident of Alexandria within, I think it's a third of a mile or so of some green space. So it's a little easier here, but it's something to think about as you're looking at buildings, is where they're seated so that the people in there can be healthy. Next slide. And I mentioned that they're biodiverse. Low maintenance native species are used both inside and really outside, and that they, again, will thrive with no or low flow irrigation. There's places like the Plant Nova Natives, certified wildlife habitat from the National Wildlife Federation, and other places where you can find good, healthy native plants. Next slide. They fit into the local land uses of what I mentioned, so they don't really add to urban sprawl. And this, even in the suburban areas, they can be built in a way that you can still walk to resources and things. We just don't want a good environmentally green building is not going to add a lot of transportation energy use for the people who are in the building. So you want to be located near to services. You want to be near sustainable transportation. And also they're going to not add to the dark sky pollution. So you can use dark sky approved exterior light fixtures as one example of how to keep them, again, kind on the environment. Next slide. So I mentioned that they're using building materials with these lower environmental footprints. They also want to be locally produced so that you have fewer greenhouse gas emissions when making the materials and then when transporting them. There's a number of options that you can look for in selecting the materials that are listed here. And again, if they're using waste materials as they're building things, if you are going to use the plastic wood, you'd probably use the product that's made in Winchester. So that, again, it's using recycled plastic bags from the grocery stores as one of its primary inputs, and it's not too far away. Let's go to the next slide here, if we would, please. Again, this whole idea of a light footprint on the environment, they're going to use electricity for almost all of the energy use. And they should have EV charging equipment or the capacity and wiring to add it later. all of these things, as David gets into this, are leading to the building on the energy side having a low energy utilization index, or EUI. There's a lot of discussion about that in the Alexandria Green Building plan that was put together. And that really is just a measure of how energy efficient the building is. A lower EUI is better. And if you have a lower EUI, then you'll need to use less renewable energy to support it. And you can have room for EV charging and things in the energy budget on the site. So again, I've gone through these very quickly. We wanted to take a little bit more time getting into the energy side of things. And so I think I'll have David take over with the next slide, if I remember right, to begin to start to talk about, again, why it's so important and dig into the energy side some more. David, it is all yours.
Great. Can everybody hear me okay?
Yes.
I guess. Okay. So in my view, energy efficiency is really the central piece of making a green building. And really it comes down to ultimately the climate. But I'll get to that. We have to think about it. I think we have to think about not only individual buildings, but buildings as part of the energy system of their community and their region, and how they contribute to climate change. So let's start just thinking about individual buildings. Energy efficiency is primarily important as a pocketbook issue right now, because 40% energy costs have gone up 40% since 2020, and they're projected to go up 100% more by 2040. So this really affects affordable communities, affordable housing, as we've stressed with Build Our Future. Actually, it's also a comfort issue. Energy efficient buildings don't have stratification between floors of the air, so you don't get very hot attics and very cold basements. There are no drafts, and there are no big seasonal humidity swings. In fact, a lot of our clients come to us not because of the energy piece of passive house buildings, but because of the comfort. It's also a health issue. You just don't get the problems of mold and poor interior air quality in energy efficient buildings. And increasingly, it's a life safety issue. Since 2021, there have been 20,000 deaths due to extreme weather events, about half of those in hot events and half of those in cold events. In 2021, there was 700 deaths in Texas when a disruption of the polar vortex created sub-zero temperatures for a week over Texas. And the system just wasn't, houses weren't prepared to handle that, and the grid wasn't prepared to handle that. Just this February, we had what's known as an SSW, and that term is going to become more and more familiar to us as the years go by. It's a sudden stratospheric warming event. And that is what it's basically it cut the polar vortex in half and created all kinds of disturbances, which we felt this winter down here in Virginia and all through the Midwest. Superior insulation and solar and battery storage of energy efficient buildings allow them to ride out these storms. And that's what we call passive survivability. Now in the community, when we think of these green buildings in the community and at the regional level, we really need to think about the fragility of the electrical grid. About 500 sabotage attacks have happened to the grid in the last 10 years. And cyber attacks are growing at 40% per year. So it's very vulnerable. It's also vulnerable to weather events and increasingly to overloading from the demand from data centers. So what does this mean for energy efficient buildings? They actually take the load off of the grid because there's less demand from them at peak times of the day. And with solar and battery storage, they can actually send energy back to the grid in peak periods. And finally, energy efficient buildings function when the grid is down. So again, it's a life safety issue. And I'll get to that in a little bit. But it's really when we come to the climate that we realize that energy efficiency is a moral issue. Buildings use about 50% of all they produce about 50% of all the greenhouse gases that come out of this country. And that percentage grows with data centers. So in faith communities, in answer to this, we really do need to act, not only in our places of worship, but in our own homes. So how do we do that? I'd like to take you through sort of what you do to make a building energy efficient. And that little diagram on the left is kind of what a typical building is. Energy is moving through every wall, the roof, and even the foundation of that building, coming through leaks, through drafty windows, and through breaks in the insulation or places where there is no insulation. And what we're looking for is more like the thermos on the right. There you've got something that's airtight, it's watertight, it's completely insulated, and it keeps your coffee warm all day. So that's kind of the goal for our buildings, and we can do it. First thing we want to do is introduce thermal insulation around the entire envelope. That is the roof, the walls, the foundation, and the windows. Then we want to make sure that there are no breaks in that insulation. And that happens every time there's a stud going through a wall, or every time there's a joint with some kind of structural element in the wall. And good design accounts for that and removes things like all those little light colored lines you see there. Those are all thermal bridges. So energy efficient buildings don't have those. So once you've got a very good thermal envelope, no thermal bridges, you now need to make sure it's an airtight envelope. And so every time you have two different surfaces coming together, like a roof meeting a wall, or a pipe going through a wall, or a conduit going through a wall, every time there's a joint or a window meeting a wall, you've got to seal that really well. And there are ways to do that, and it's not difficult. It just has to be done, and it's something that builders are now coming to understand more. And finally, you need to be sure you've got airtight and insulated windows and doors, insulated not only in the glass, but in the frames. So once you've got all that, you've got a perfectly good building envelope, and very little energy is moving through it. But if you don't deal with the sun, a lot of unwanted energy will get to it. So we want that sun in the winter, and that's shown by the low sun coming in deep into that building. This is a section of a building. And then the summer sun, we want to keep it out. So we build things like overhangs or add overhangs here. But there are certainly other ways to do it. We do it with awnings. We do it with exterior shading. It really depends upon the orientation of the building and the design of the building. But there are lots of options as to how to do it. So now we've got a perfectly good building envelope. Very little energy is moving through it. So little energy, in fact, that the heating and cooling loads for that building are less than the hot water heating loads now. So now we've got to make sure that we've got very efficient equipment inside that building, because they generate a lot of loads themselves. The first thing we want to do is look at our heating and cooling. And we use, in energy efficient buildings, you want to use heat pumps. They're about 50 to 75% less energy than traditional systems. The city of Alexandria, I just read this week, announced a $2,900 incentive for swapping out your existing heating and cooling system and replacing it with a heat pump. So you may want to look into that. Now, remember I said that these buildings are airtight, and that's fine in days like today when you can open the windows. But in the cold winter and the hot summer, that building is going to be sealed up. So you have to mechanically ventilate it. And what we use for that is what we call energy recovery ventilation, or ERVs. And it's basically a simple fan that takes in fresh air from the outside and exhausts stale air from the inside. And those two air streams pass over each other and exchange both heat and humidity. And that's about 90% of the energy is saved, that of the incoming air, of the outgoing air, and about 50% of the humidity. That compared to no energy being saved by ventilation the old-fashioned way, which was through cracks and drafty windows. I mentioned the hot water being a big demand. We now use heat pump hot water heating, and that is about a 50 to 70% more efficient than gas or electric hot water heaters. And it also avoids the dangers and the byproducts of burning gas. Particularly in a tight house, you do not want to be burning gas in there. Similarly, heat pump dryers use about 50% less energy than traditional dryers. And we all know about LED lighting. It uses about 10% of the energy of incandescent lighting. And most of us have already made that transition. A lot of us are now making the transition to induction cooking, which is probably, I think it's 20% more efficient than resistance cooking, and about 50% more efficient than gas. And finally, any other appliances that you have in your house or your building need to be Energy Star rated. They're typically 10 to 50% more efficient than the comparable appliances that you could buy. So with all of that, you now have about a 40% overall energy reduction just from changing your equipment to heat pumps and highly efficient things like your ERV. And if you think about the building envelope and making upgrades there, that's a total of about a 75% reduction in energy from both the envelope and the equipment. And we've actually seen that in our retrofit projects. We've done deep energy retrofits, and we often achieve a 75% reduction in energy. Now that you have a very good building, either because you've retrofitted or because it's a new building, now is the time to think about solar and battery storage to make that building independent and actually energy positive. And this is a diagram of kind of an overview of how that works. And there's a lot of detail I could go into, but I'll try to stay out of it. I could get into it if you have questions later. Basically, the sun creates direct current energy in the solar panels. That direct current energy comes into the building to an inverter. And the inverter is kind of like the traffic director of the building for energy. It can send that energy into storage in your EV. It can send that energy as direct current energy into your battery storage in the house or the building. And it can also go to DC loads that are in the building. Likewise, it can convert the energy into alternating current or AC energy and provide energy for all the household loads. And it can also send it to the surplus to the grid. And on the converse side, when the power is down and the grid is down, when you need energy because you've run out of energy, it's been cloudy, and you've had a lot of energy use, you can import energy from the grid and store and send it back to your battery, back to your car, or go directly to your household loads until you're balanced out again. Now, when there are grid outages, you can disconnect, and that's sort of what that is. You basically just come off the grid, and now your house has become suddenly it's now a nanogrid. It's completely independent of the grid and can function on its own. And that's hugely important for these weather events that I've been talking about and the sort of threats to the grid. When you take this nanogrid and you hook it up to other nanogrids, other buildings in a neighborhood, you now have a microgrid. And this is a diagram, very diagrammatic, of what that microgrid might look like, and also what the future energy grid really looks like. So here you see you've got local power generation from solar arrays, from, in this case, we put in some wind, and solar roofs. And you've got storage in that community from community storage over here, storage in EVs, and storage in houses. So that community is completely self-contained and can, when it's got a deficit of energy, it can import energy from the distant grid, from the power plants through the grid and back into this community. And likewise, when it has a surplus of energy, it can send energy back into the grid. So that is a really critical piece, and that is the difference between the new grid and the old grid. The big takeaway is that this community can survive when that grid is down. If there's an EMP or there's an attack on the grid, this community can survive. The hospitals in that community can stay open. And likewise, when the grid is down for weather events, this community can continue to function. And also, it's a big help to the grid, because now when you think about it, the grid is no longer a one-way trip for energy from distant power sources to a community. It is a balancer of energy. So it is basically taking the overflow energy and sending it to other places, or bringing energy in if you have a deficit. But so the loads are dramatically reduced, and that takes the pressure off of the grid, which is already at its breaking point. Now, one last thing I'd like to talk about is how that grid is going to behave in the future. The future grid, and this is already happening, the future grid is going to be a peer-to-peer transactional economy. What that means is energy is going to be traded minute by minute using blockchain as sort of the account keeper. Buildings will be prosumers of energy rather than consumers of energy. And so their efficiency is going to matter in how they fare in that economy of energy. So you'll be trading energy with your neighbors or buying energy from your neighbors. And this is already happening in a pilot project in Australia, and it's been quite successful, where homes are linked like this and they're trading through blockchain. And I think that is the future that we're going to be seeing. But we have to remember, the bottom line is that an energy efficient green building is the cornerstone of this whole grid economy. So that is kind of an overview of energy efficiency in buildings. And I'm going to go to the next slide for Steve.
Thank you very much, David. There's one of the questions we often hear is, how do you know that a building is green? We talked about the certification at the beginning. And there are tools that can measure the design construction, and this term commissioning means testing out the building to make sure it works as it's designed, and then the operation. And there are tools for existing buildings as well as for new buildings. There's a long list. And David has been talking a lot about passive houses, and which are really net zero, these well-designed, efficient net zero energy houses that uses that's called the passive house standard. But there's any number of these. They all have their strengths and weaknesses, but what they do is they give you a framework to be able to go through and do the building right. And so if you're thinking about doing something to your buildings, be it at your congregations or in your existing buildings or where you work, working with somebody from these sources who know these sources are a way to so that you're not starting just with a blank sheet of paper, but you've got some different things to work on. LEED is one we've heard about for a lot. And the Alexandria Green Building Plan went away from LEED as its basic approach to what a green building is. Um, but LEED has been improving, and so the LEED Zero is a better from an energy standing performance is a better tool. And it also picks up the other components of LEED buildings, such as its siting, its use of recycling, it's all the other things that we mentioned, use of water and others. Um, these others, again, Earthcraft is a little bit more geared towards residential buildings. Um, and again, on homes, the U.S. Department of Energy, you can still find things out there about their zero energy ready homes or zero emission homes. Um, for existing buildings, there's other types of certifications that can be used for those. Um, and the um, and so again, you don't have to just think about the ones that are there for the new buildings. Moving on to the next slide. I mentioned that there are people out there that can help you. Um, by the way, David showed the picture of the building, the thermal camera on the building, and the shot of that's my front door before I did the air sealing on my front door. So you can see how um, we take these houses on, and we've got lots of things that we need to do on them. So now that door is much better sealed up. Um, but that again and that camera was the camera that I got on loan from the Alexandria Public Library system that just fit on my phone to be able to take pictures of the thermal pictures of the building. So that's available here. So the Office of Climate Action has those types of tools available, as well as the Eco City Home, Eco City Business certifications. I mentioned the borrowing the thermal cameras from the library. You can also get the plug-in watt meters from the library. So you can plug something in there to get a good sense of how much power that actually is using. If you're thinking that you are turning something off, but you're worried that it's still maybe using what's called phantom energy, you can use the plug-in watt meter for a little while on there to see if it actually is turning off when you're thinking you're turning it off. Um, there's also Rewiring America, not American. I see that's a typo I have in there. Um, that provides coaches that will help you plan how to change out your fossil fuel equipment to electric. There's a no charge program. So these are volunteer coaches that are out there available here in Northern Virginia, as well as elsewhere. And what that does is it helps you get a plan in advance so that you're not scrambling around if your air conditioning or heater goes out in the middle of the hot or the cold weather and you're scrambling around, or if your hot water heater goes out and you're scrambling around because you don't have hot water, you have a plan on how to approach it. And so it's a very interesting and good service. There are some home energy audits that you can do for free from Dominion, although there are other better audits that the auditors will do. And there's groups like Veridant, which provides technical help implementing these green building technologies. And so you can go out to their site and get a lot of good information. So you're not alone in this. And there's other professionals such as David and others that can help you too. So you're not alone. And but this gives you some places where you can look. Going on to the next slide, please. I think that was maybe the last slide.
I
And
think so,
so
yeah.
with that, I think we're gonna like to open it with questions. I think we've just been at 35 minutes, so we've tried to keep it, I know, very quickly going through this at a fairly high level, but we wanted to give a chance for people to ask questions or have discussion here about what makes a building green.
Yes, I'm going to suggest that if you have a question or a comment, that you raise your hand if you know how to do that at the React options. If you do not know how to do that, there's a place at the bottom that says raise hand. If you do not know how to do that, then just put your name in the text or raise your hand. Everybody is not on the same screen, so I might miss you if you first time around, but I'll try to catch everybody. So I see Anne Marie has got her hand raised. Go ahead.
Yeah, thank you. Um, you mentioned DC loads in buildings. What are you referring to? What examples? I mean, can you get like DC stoves or DC,
I'm glad
yes,
you asked that.
yeah.
The direct current is, I think, everything's going to go to direct current because we generate energy in direct current, we store it in direct current. All of our electronic devices are driven by direct current. All the motors in our appliances are direct current motors. They've just got these little boxes on them so they can sell them in an AC world. But already in the third world, kind of like what happened with cell phones skipping landlines in the third world. They are making direct current appliances for already big manufacturers. LG already makes a complete line of appliances in direct current, and they are just beginning to consider bringing them into this country, but there's not really a market yet. So about most of the loads in your house, heat pumps, everything that we do, except maybe our toasters, can be direct current in our houses. So what we do in my practice is we try to plan for that eventuality that we are going into a direct current world and that the houses can make that transition. And it's the same with larger buildings. I've put everything in terms of houses because that's what we do, but all of these principles apply to larger buildings.
In
But
some of the
you
larger
need,
buildings, they're designing a direct current distribution system in it so that the computers connect directly into the DC power today. And so I think, for example, the American Geophysical Union did that, where you don't have the same power supply on your computer that you do with an AC system. You don't have to have the big box there, but it connects directly into a DC circuit. So we're beginning to see that in some of the commercial buildings, a little bit ahead of some of the appliances showing up in residential buildings.
I think the other piece of that is that it's just so much more efficient because every time you make that, when you think about typical solar systems, it comes in as direct current. It goes into a little transformer that sends it across your house to your battery, and then gets converted back to alternating current, again, losing energy. Comes out of the battery, goes across the house to your refrigerator as alternating current, and then gets converted again to power your refrigerator as direct current. So it just doesn't make sense. And I think it's the future because it's economical.
I also want to thank Jennifer for posting the connection for the Alexandria Library in the chat for the cameras, the thermal cameras. Thanks, Jennifer. And I know there are a number of Arlington people here, so if you have resources that you could share on the chat, or if you want to talk about them, that'd be great. And I do see, speaking of Arlington, I do see John Bloom's hand raised. Go ahead, John.
Thanks, Donna and David and Steve. Great presentation. And I guess the broader question I have is, do we want to talk a little bit about not just what is a green building, but how we can
If
get
there's
more of them?
wine open, I'll have some.
I think it was,
Tom O'Reilly, could you mute
I'm sorry.
yourself? No
I'm
problem.
sorry. I'm sorry.
So kind of policy-wise, how can we get more green buildings in Alexandria and Arlington? And I'll give one example of a policy that's right now under review in Arlington, which is the standard site plan conditions that Arlington sets. That's the minimum conditions for every site plan project, the big projects. And right now it's way too low. And so, the challenge for us is to figure out how to raise it to incorporate as much of the kinds of green building aspects as we've been discussing here in a context where the county is very concerned about economic development and frightened of scaring off development. And also when there are many, many different community benefits like affordable housing that are wary of, that if we do too much on the green building side, then developers will have less kind of extra funding to provide affordable housing and so on. So it gets complicated, but that's something we're facing in Arlington right now.
We have just faced that in Alexandria. And I think the city council of Alexandria did something kind of heroic this January in passing a green building plan, which really has teeth for all of the special use permit projects that go up in our city. We can't do anything about the building code because we're a what do you call it? Dillon rule state. But we can for anything that's by right, we can't do anything. But if you're getting special permission, they said from now on you're going to have to make energy efficient buildings, and not just through LEED and gaming that system, but actually performance based. And that's what the EUI standard is. I don't know if you're familiar with that in Alexandria, but that actually requires really good performance of buildings. And of course, the developers fought it. And they've used all those arguments that they've used for years, that you can either have green or you can have affordable, but you can't have both. And we have, at Build Our Future, we put together a couple of webinars that address that question. And you can have both. And in fact, with energy costs today, you need both, because an energy inefficient building is not affordable. And so, but the jury's out, because the developers have written to the city saying, we're not going to develop in your city anymore. We're going to other places. And I was just by the Potomac Yards JPG owned land that's around the Virginia Tech building, and they're letting the grass grow. They're making sure that we know they're not coming back. So the city is committed, though. They said, this is enough. We're not doing this anymore.
So there was a lot of debate over how low the energy utilization index should be for various types of buildings. And we did a lot of documentation as to how low it can be and still be cost effective. The city council didn't go as low as we were hoping, but they went quite a bit lower than that, a lot lower than the development community had asked for. The development community had asked for numbers that wouldn't have even met building codes. And so if you want to look at the green building plan that Alexandria just put together, that might be a starting point. And we also made a lot of points about the kind of the total cost to keep a building running and almost immediate payback for these types of improvements on many of these types of buildings, so that in talking about housing affordability, and not just affordable housing, but across the full spectrum, we were able to successfully make the argument that when you add utility costs in housing, that these green buildings are going to be as or more affordable as the standard buildings that were being built. And so we could spend some more time with the people in Arlington about the specific arguments that we made. There's been a couple of comments in there, and I just wanted to just quickly address some of them. One of which, in talking about AC versus DC, made the point about that AC was put in place to more allow larger amounts of power to be moved over longer distance on the transmission lines. There are efforts being made at doing long distance DC power transmission lines, but most of them are AC. Most of that is AC now. And so the technology, though, is changed some from what was first done when we put AC to be able to move the power more efficiently over these long distances. The whole issue of the grid is something that really is going to need a lot of work. And also somebody mentioned the group heat pump purchasing co-op being set up in Arlington under Switch Together Arlington. There is also Switch Together Alexandria, and I should have put that on the slide of additional of places that you can get some help. And so the Switch Together is a fairly recent group that has come around into this area to allow group buying, much the same as the Solar United neighborhood group does it for solar systems.
Thanks, Steve. And thanks, David, for that question. Chris Rosenthal has a question. She said, "What's coming up for energy storage in a residence? Last time I checked, it was very expensive."
I'll address that briefly. I don't have exact numbers, but there's a kind of an S curve for adoption of and costs for solar, and then about 10 years behind it is the curve for battery. And so the prices for batteries are going down like the prices for solar went down in the 2010 to 15. So they're coming down fast.
And there's some different battery technologies being developed, some solid state batteries and things that have the potential to, but again, until they actually meet the mass market, they're just still in the potential stage. I think another place that some businesses are starting out there is the reuse of vehicle batteries for buildings. And so that is again, it's a business, some businesses are starting that you don't have to have the fast charges and discharges that you need in a vehicle when you're using them in a building. And so there are now some that are coming to the market that are reusing the vehicle batteries. But again, the control systems, the technology behind these systems are still being fine-tuned. And so I think there's 3 companies that I know of that are doing that now, and they each have their own type of computer controls on the system so that they can use the different batteries at different stages of wear out. So those are happening, but it is still fairly expensive now, as Chris pointed out. It's something that we'll want to keep our eyes on. Early adopters are going to be, again, a place where we can learn from. And then I think as an economic development approach in Arlington, Alexandria, Fairfax, and elsewhere, we need to be looking at these companies who are developing the types of control systems for these things. And that's a way to kind of build off the green economy here in our area. We probably won't have the manufacturers here, but we can have the smarts behind the systems be developed here.
Thanks, Steve. Thank you, Chris. I did notice that earlier in the chat that JD is experiencing with United Methodist Church what a lot of places are. Everybody wants to go net zero, but it's like there's some real commitment required for that. So I think JD wants to hire you, David, to help,
I'm happy to
help move his congregation.
Yeah.
Well,
I'm happy to spread the word.
it's all of the United Methodist churches in Virginia that are committed to doing that.
Ah, I see. Yep.
And so we have been meeting with our conference, that's the diocese level people, saying, okay, we passed this resolution 2 years ago and nothing's been done. What are we planning to do now?
Yeah.
And so, and I will follow up with the presenters and see what we can do.
Sure, I'm sure they'll have a suggestion about how you might go forward.
If we can't do the whole of Virginia, we can maybe do the Northern Virginia district.
Sure. Yep. You start where you can.
We got 110 churches in Northern Virginia district, the most in the conference.
Yeah,
Wow.
that's a sizable number, and it would make quite a difference to get them net zero.
Mhm.
Anne Marie, you put your hand up again.
Yeah, you just said diocese. Are you working with non-Christian denominations also?
Um,
Could you? You might you.
So,
yeah,
faith, so
yes,
fax is
fact,
open to all, whether
yes.
it's Christian or non-Christian, and we do have some non-Christian members and congregations or worshipers within fax.
So the answer is that, I know there are different opportunities that fax creates for people to come together to talk about how do we move this in our churches, and certainly the Alexandria, Arlington, several jurisdictions, certainly Fairfax. How do we move this in our communities? So those are things that it's a lot better if we manage to do that together. We have a lot more impact. So that's a lot of what FACS is about. Do I have, let's see, do I have any other questions? Let's see,
I think
There was
Joanne,
a question
yeah,
from David
yeah.
Yaffe, which I'm not sure I understand, but
No, I think Steve tried to answer that question, didn't you,
okay.
Steve, from David Yaffe?
attempted, yes. I see Joanne Holton put something about
Yes.
a film product that she saw on a UK trip, is a thin solar film on existing slate roof. There are a number of different materials. Is this something that is, I'm not familiar with it. So is it generating photovoltaic power from that?
That's my
Or
understanding, Steve. And actually, I apologize. My fellow properties committee person who's a historic preservation architect was recently in the UK conferring about things that they're doing over there, places like Westminster Abbey, and she observed this material. Apparently, there is a German product. And then there's this one American supplier that she located. I was meaning to use quotation marks to explain that this was my
Mhm.
my friend who did this. But anyway, American distributor Heliotech. Apparently, she found online. So I didn't know if you all would know anything about products of that sort. We are historic parish located downtown across from the White House. So we have a lot
I,
of constraints in terms of what we can do on
yeah.
our
I know
roof.
that there's been a lot of building integrated photovoltaic work over time. There were different types of thin film windows that were produced for a while, actually at a plant in Virginia until BP closed the plant and moved elsewhere, and then got completely out of the business. Um, the Virginia Tech building, right where David was talking about, where the grass is still growing on some of the other lots, has building integrated PV in some of the glazing on that building. So there's products right there that, and if you can do some research on the products in that building. Um, and so that is a fairly new, well, it's an old development, but it has gone up and down. And so I think that there's a lot more work that needs to be done on the building integrated PV. The thin films, um, the ones that I've seen in the past have tended to wear out pretty quickly,
Mm,
and not weather very well.
yeah.
And so it'd be really interesting to see this product and look at some of the history that is there. Um, and it would certainly be a interesting improvement on historic buildings if it works as you're describing.
Yeah. Thank you.
Thank you, Joanne. Chris, I see you've got another question in here. Do you want me to ask it for you? Sure. She says, I'm sure greening existing buildings is difficult. Are there leaders in rehabbing multifamily buildings we can study?
David, do you have some experience with that?
Well, Um, I'm glad she asked the question. I don't have the answers. We have been trying for several years to get grants to do a pilot project of rehabbing multifamily buildings in Alexandria. It's we so much focus on new buildings, but in the built up DC metro area, it's the existing buildings that are the real challenge. And we've got so many of these post World War II walk up apartment buildings that are the worst offenders. And they would be so easy to make a huge change with. Um, and our office actually did a study of some buildings on Glebe Road and looked at the costs and the energy savings. But we just haven't been able to generate the interest from many developers.
I've seen a little bit of work going down in the Richmond area that they were trying to do some renovation of multifamily buildings to be much more energy efficient. But it's been at a small scale. I think that there's a lot of issues with multifamily buildings, and there's something called the split incentives that the building owners who would make the investments don't pay the energy bills. They pass them through to the tenants. And so the Institute for Market Transformation has developed different types of leasing tools that that they can use in buildings to help address those issues. I think the Institute for Market Transformation has probably been maybe one of the leaders looking at this issue. But again, it's been a difficult thing. Alexandria put in place, and although it's not been used, the PACE program in order to be able to provide some lower risk, lower interest rate funding to be able to go into these buildings and do this work. DC has done more in PACE. One of the places that they've done it in DC is with some of the affordable housing projects where they're going back in and retrofitting these buildings using the PACE funding. And so the urban, I've just lost the name of it. But when you look at some of the multifamily buildings up in the northern part of DC, up around the old hospital up there that are being renovated, they're using that as a funding source and so there's some examples up in DC. But there's a lot more that we'll need to do to build that market.
Well, I mean, this is certainly, I'm certainly learning a lot in this presentation, and I really appreciate Steve and David's efforts here. We could take a final question or two if there are any. I'm not seeing any hands raised or anything in the text, so I think we're going to end at 8 o'clock.
Yeah, just one thing on the existing buildings, just to add, using the building energy performance standards is one of the ways that kind of a policy approach to be able to address getting these improvements done in existing buildings. And again, DC has been one of the leaders on that. Montgomery County is moving on that. It has been difficult to get over the authority hurdle in Virginia to be able to do the building energy performance standards. But that is one policy approach, that you set a standard and that the buildings have to make certain levels of improvement over time. And then you provide funding for it through the programs too. And if they're below a certain Energy Star score is when they would have to make these improvements. So from a policy perspective, that has been one of the more effective approaches in dealing with existing buildings.
I would like to just add one thing too. You mentioned third-party certification, and I just wanted to point out, people say, well, that's an extra cost for a project, but what we have found that is so good about third-party certification is that you have a third party looking at your architect's design, what your builder is doing, and it's an insurance policy for you who are putting that building up. to make you know that other eyes are looking at it. So we as architects also have really valued that.
Great. Thank you, David. Well, thanks everybody for coming tonight and the great questions and good discussion. And I'm hoping that we will be able to distribute the recording, but I think we will also try to get the PowerPoint out at the very least. All
I
right.
just want to say thank you on behalf of Arlington. I think half of us are from Arlington, and we're really, as John said, we're really struggling with we're really struggling on the policy side. So I think Steve will definitely want to be talking to you. Making the case on the affordability is really, really top of mind here. I mean, we have the big developer issues, but we also have affordable housing, where we've had some misunderstandings. And we feel like the doing the math was not probably wasn't done as well as it could have been. So thanks for offering to advise us and doing this session and inviting us, Donna and Steve.
Absolutely. It was wonderful to have you. It's always good to do things jointly.